470 plus something, and the activity is crashed. We will see from this diagram, and then we will finalize. Okay, so now we need to see whether we can crash D or F. Okay, so let's look at the table again. The cost of crashing D is 25 and the cost of crashing F is 30. Now obvious choice is D. Okay, but if you look at the diagram, by crashing D, can we reduce the project duration by 1 day? It is not possible, because still the project duration will remain the same. Okay, see, it is 10, it is 11. Okay, so no, we can see here. Okay, D is 25 and F is 30. So D and F we have. If we reduce D by 1 day, then the project duration reduces to 23 days. Okay, so we can crash activity D. So we can crash this activity D and reduce the project duration by 1 day. So just check. So we are reducing it to 10 days, and here activity which we crash is D. Price of crashing D is $25, and we can crash 4 days, but we will not crash 4 days, we will crash it by only 1 day. Okay, so 470 plus 25, so it is 495 now. So we will fill this table. 495 plus 300, so it is 795. Okay, now if we look at this graph, okay, now do you see any change? We see a change that the critical path has changed. There are two not critical path, the longest paths. There are two longest paths here. This is also the longest path, and this is also the longest path. Okay, so F remains the same. F is 5 days. So this path is also the longest, and this is also the longest now. Okay, so how do we go about the choosing which activity to crash for the objective of reducing it to 22 days? So now our new objective is to reduce the time to 22 days. Okay, so same process, we will copy all this all these network diagrams boxes as it is. A by 2x, okay, B by 6, E by 8, G by 6x, C will leave it blank, we'll see. F again we leave it blank, we will see. And D also we will leave it blank, and we will see. Okay, so it is like this as of now. Okay, so total direct cost is 495 plus something, and the activities crashed. We will see which activity can we crash. Okay, so this is our longest path, this is also a longest path. Okay, now look at this diagram. Which activity should we crash? A and G we cannot crash, it is already at its maximum 6x 2x. Okay, now we have the activities C and D and F. Which one should we crash? Let's look at this table again. Okay, so here we have the cost of crashing C is 30, cost of crashing D is 25, and the cost of crashing F is 30. Now obvious choice will be crashing D. Okay, D is 25, but if you look here, if you crash D by 1 day, can we get the objective, can we fulfill the objective of reducing the time to 22 days? No, because we still have this as the longest path. So in order to crash and reduce crash an activity or a set of activities and reduce it to 22 days, the best choice is to crash activity F, because this, although the price is $30, we can achieve the objective of crashing, reducing the time duration by 1 day if we crash this. Otherwise we would have to crash these two activities together to reduce it by 1 day, because both are running parallel. Okay, and both activities if we crash only one, we cannot reduce the total project duration by 1 day. So we'll have to crash both of these, and the cost of both of these is pretty high. D is 25 and C is 30, so it is 55. So it is a wise decision to crash only F. Okay, so our next graph would look like this. F will be reduced to 4. Okay, and do we have a provision to crash it further? No, so we write it as 4x, and these remain the same, 10 and 10. Okay, so activities crashed, we will write F, and time due, and the cost is $30. Okay, so here again we'll write 30. So the total cost is 525. Okay, so we'll plot in this as well. 525 plus 250, it is 775. Okay, again same process, we will try to change the time duration by 1 day, reduce the time duration by 1 day. Okay, so our task is to reduce the project time by 1 day and make it 21 days. So same process, A 2x, B 6, E 8. Or before proceeding, we forgot one step. Now let's see, look at the network diagram. What has changed now? If you look carefully, this is reduced and it has become 22 days. Okay, 2 plus 10 plus 2 plus 4, 16 plus 6, 22. This is also 10 plus 2 plus 4 plus 6, 22. And if you look at the upper one, okay, 10 plus 2, 20, 8 plus 2, 10 plus 6, 16 plus 6, 22. So now all the paths have become the longest paths. So there is a huge change in our network diagram, and all paths have equal number of days. So now it is something very tricky. Okay, so although we have written it, so we will just see C by 10, we will change. Okay, we'll overwrite. I have written all. 4x we cannot do anything, this is fine. G 6x, okay, fine. Okay, and D although we have to change, but we are not changing as of now, we'll see. Now, since all paths are the longest paths, so again we will try to create the template. Total direct cost is equal to 525 plus something, and the activities crashed, this will be we'll see. Okay, so let's look at this diagram only. Okay, I think this is slightly better. Okay, what is the this we have to crash D, we have to crash C, and out of B and E something has to be crashed. So again, let's go back to our this table. Okay, so what are the activities that we need to check? We have to check for B is for